Everyone. Welcome to our online class. So now in this class we will see Cayley-Hamilton theorem. Problem on Cayley-Hamilton theorem. Okay. So what is Cayley-Hamilton theorem? Cayley-Hamilton theorem states that every square matrix satisfies its own characteristic equation. What is the Cayley-Hamilton theorem statement, ma? Every square matrix satisfies its own characteristic equation. Now see the problem here. Verify Cayley-Hamilton theorem and find A inverse and A power 4. What is asking? He is asking, sometimes this type of problems will come for directly 14 marks. So he is asking A inverse and A power 4 for the matrix of the matrix A is 1, 2, minus 1, 2, 1, minus 2, 2, minus 2, 1. Okay. So we'll solve this problem in this video. Let us see. So first what we have to find? We have to find characteristic equation. Correct. Now solution, see here, solution, characteristic equation. Characteristic equation, what we have to write? Mod A minus lambda I is equal to 0. Correct. What is characteristic equation, ma? Mod A minus lambda I is equal to 0. That is the characteristic equation. That means what I get here, this implies mod. So subtract the lambda from the diagonal elements, ma. So what I get here, mod, compulsory you have to write mod 1 minus lambda, 2 minus 1, 2, 1 minus lambda, minus 2, 2 minus 2, 1 minus lambda. Correct. Now you have to find the determinant over here. So if I find the det over here, so what I get here, see here. So first 1 minus lambda. So this row, this column we have to leave. So this row, this column. So 1 minus lambda into 1 minus lambda, 1 minus lambda whole square. That means A minus B whole square, ma. A square plus B square minus 2AB. Next minus 2 into minus 2. How much it is? 4. Okay. So this minus you have to be very careful. So many students, they will forget to write this minus. AD minus BC. Okay. Next minus 2 into this row, this column, ma. So 2 into 1 minus lambda, 2 minus 2 lambda minus 2 into minus 2 minus 4, minus of minus plus 4. Next minus 1 into this row, this column. So 2 into minus 2 minus 4 minus 2 into 1 minus 2 minus of minus plus 2 lambda is equal to 0. 2 lambda is equal to 0. Okay. So now simplify this characteristic equation. What I get here? So if I simplify this one here, so 1 minus lambda into what I get here, lambda square minus 2 lambda minus 3 minus 2 into minus 2 lambda 2 plus 4 6 minus 1 into 2 lambda minus 6 is equal to 0. Next again multiply this with 1, ma. So if I multiply here lambda square minus 2 lambda minus 3 multiply by minus lambda cube minus into minus plus 2 lambda square plus 3 lambda minus into minus plus 4 lambda minus 12 minus 1 into 2 lambda plus 6 is equal to 0. If I simplify this, what I get here, minus lambda cube, lambda square plus 2 lambda square is how much? 3 lambda square minus 2 plus 3 1 1 plus 4 5 5 minus 2 3. So plus 3 lambda plus 3 lambda. Now constants, ma, minus 3 minus 12 minus 15 plus 6 minus 9 is equal to 0. Correct. So multiply by minus, what I get here, lambda cube minus 3 lambda square minus 3 lambda plus 9 is equal to 0. This is the characteristic equation. What is this? This is the characteristic equation. Now what is the Cayley-Hamilton theorem says? Cayley-Hamilton theorem says every square matrix satisfies its own characteristic equation. That you have to write here. So therefore by CH theorem, Cayley-Hamilton theorem, what is that? Every square matrix satisfies its own characteristic equation. Okay, every square matrix satisfy its own characteristic equation. That statement you have to write, ma. So now what you have to do, you have to substitute in place of lambda you have to substitute A. So this implies what I get here, if I substitute here in place of lambda a, I get a cube minus 3a square minus 3a plus 9 is a constant, so you have to take it as unit matrix 9i. So this should be how much we have to get, ma? 0 we have to get. Correct? So that means a cube. So the given matrix is there, no, a. So you have to find a cube of the given matrix. So you take the calculator and substitute the values here. If I substitute the values, so a cube using calculator, ma. So using calculator, so I got the value of a cube. I got the value of a cube. How much I got here? 324, then minus 21. Then second row 621 minus 24. Then third row 6 minus 6 3. So using the calculator, I got the value of a cube. How much I got? 324 minus 21 621 minus 24 6 minus 6 3. Then I get next a square into 3a square. So 3a square, how much I am getting here? 9 3a square, no, 9 18 minus 18, then 0 27 minus 18 0 0 3. Okay, next minus 3a, multiply the given matrix by 3, ma. So 3 6 minus 3 6 3 minus 6 minus 6 6 minus 6 3, then plus 9i. How much it is? 9 0 0 0 9 0 0 0 9. Correct? If I simplify this one, how much we should get? We should get 0. Correct? Let us see whether we are getting 0 or not. So therefore this is equal to 3 minus 9 minus 6 minus 6 minus 3 minus 9 plus 9. How much it is? 0. Next 24 minus 18 6 6 minus 6 0 0 plus 0 0 minus 21 minus of minus plus 18 minus 3 minus of minus plus 3 0. Correct, ma? So like that, so we get all the values are 0. So how I got these values? Using calculator. So therefore Cayley-Hamilton theorem is what? Verified. So what is that? Cayley-Hamilton theorem is verified. Why? We got 0 matrix. Correct? So therefore you have to write here, therefore CH theorem is verified. CH theorem is verified. Understand here? So very simple it is. You have to find characteristic equation and substitute the matrix in that, and find a cube, a square, whatever the values, then add those all values, you should get 0. If you should get 0, then Cayley-Hamilton theorem is verified. Okay, now what is asking? He's asking to find a inverse and a power 4. What is asking, ma? He's asking a inverse and a power 4. Now how to find a inverse? Using characteristic equation itself, you have to find the inverse. Let us see. So to find a inverse, what we have to do, ma? So first we have to write the characteristic equation from characteristic equation. What I got? Characteristic equation: a cube minus 3a square minus 3a plus 9i is equal to 0. This is the characteristic equation. So many students, they use the calculator and they find simply a inverse, they'll write the answer. It is not like that, ma. So you have to solve using characteristic equation only. So what we have to do now? Send these all terms to right hand side. What I get here? 9i is equal to minus a cube plus 3a square plus 3a. So both sides multiply by a inverse. Both sides multiply by a inverse. So what I get here? 9i into a inverse is a inverse minus a cube into a inverse is how much? A square. A square into a inverse is what? A. 3a into a inverse is what? I. Okay. So send this 9 that side, ma. So a inverse is equal to 1 by 9 minus a square plus 3a plus 3i. 3a plus 3i. Okay. So this is the value of a inverse. Now what we have to do? Using calculator, we have to write, we have to find a square, then 3a and 3i. Correct. So what is a square value, ma? So now see here, using calculator, I got a square. I got a square. How much I got? 3. So minus is there. So minus 3 minus 6, minus 3, minus 6, plus 6. So then 0, minus 9, plus 6. Then 0, 0, minus 3. This is the value of a square. Then 3a, 3a is what? 3, 6, minus 3. 6, 3, minus 6. 6 minus 6, 3. Then 3i is what? 3, 0, 0, 0, 3, 0, 0, 0, 3. Okay. So therefore, how much I get here? 1 by 9. If I simplify this into, if I simplify this, what I get here? So minus 3 plus 3, minus 3 plus 3, minus 3 plus 3, 0. I get here 3. Minus 6 plus 6, 0. Okay. So then 6 plus 6 minus 3, 3. Then 0 plus 6, 6. Minus 9 plus 3, minus 3 I get. Then here 6 minus 6, 0. 0 plus 6. Then 0 minus 6. Then minus 3 plus 3, 0, 3. Okay. So now you have to divide by 9 here. If I divide by 9, what I get here? 1 by 3, 0, 1 by 3, 2 by 3, minus 1 by 3, 0, 2 by 3, minus 1 by 3, minus 2 by 3, 1 by 3. So this is the value of A inverse. That is the value of A inverse. Like that, you have to find A inverse using Cayley-Hamilton theorem. Using Cayley-Hamilton theorem. Understand this problem? So very, very important. Sometimes he will give you Cayley-Hamilton theorem to find A inverse and A power 4. So now we calculated A inverse using Cayley-Hamilton theorem. From the characteristic equation, take remaining terms to that side and constant this side, then both sides multiply by A inverse. So cross multiply by 9. Then using calculator find A square, then 3A and I, so you will get the A inverse. Now similarly, what you have to find? A power 4 you have to find. How to find A power 4? We'll see. Okay. So to find A power 4 from characteristic equation, what we have to do, from characteristic equation, A cube minus 3A square minus 3A plus 9I is equal to 0. Correct? So keep A cube this side and send these remaining terms to another side, So what I get here? A cube is equal to 3A square plus 3A minus 9I. Right? So both sides multiply by A. So if I multiply here both sides by A, so what I get here? A power 4 is equal to 3A cube, 3A square minus 9 into IA, I get A. So that is the value of A power 4. A power 4. Okay. So if I find A power 4 using the calculator, so here I have to simplify. I have to find A cube, A square and 9A. So it's a little bit lengthy, no space here. So I'm directly writing the answer here using the calculator. A power 4 I got 972 minus 72. Then second row is what? 0, 81 minus 72. Then third row is what? 0, 0, 9. Like this, you have to find A power 4 using the Cayley-Hamilton theorem. Here the equation is important here. So for A inverse, what we did? We did both sides multiplied by A inverse. Correct? Now here to find A power 4, what we have to do? We have to multiply both sides by A. Understand here? So like this, you have to solve this problem using Cayley-Hamilton theorem. A inverse and A power 4, both we have to solve. Understand here? So take down this problem and practice this problem.